All right. Hello, everybody. So my name is Ron. I'm here to talk with you about distributed tracing in serverless systems. I'm very happy to be here. Um, in this session, you will learn why distributed tracing is a key component for monitoring serverless applications correctly. So I work for Epsagon, a startup company from Tel Aviv. And on Epsagon, we aim to revolutionize the way that monitoring serverless application is done. We think that monitoring for serverless application is a new and big challenge, and we think that the current classic solutions are not good enough for this kind of application. And distributed tracing is one of the things that can really help us doing correctly. So a little bit about myself. I'm a senior engineer at Epsagon. I live in Tel Aviv. Before that, I did a lot of cybersecurity on the intelligence forces in Israel. I have also a master in mathematics, but don't worry, no more maths in this session. Okay, so that's it. Now, distributed tracing is about monitoring, about being able to observe what is going on inside your systems. So let's first understand why do we need that. The first thing could be to check the system health. What are the current problems? Because we always have problems, and to be notified about new problems or new errors. Then we will need to troubleshoot and fix these problems, and in production, that can be quite hard. Moreover, we always want to optimize our applications in terms of performance and cost mostly, and especially as the application changes from time to time, we always need to keep track and to optimize it. So I think it's quite clear that everybody needs some monitoring abilities, and it's not a new thing. We always had this monitoring problem. But what happened that our application changed from monolith application that the code was executed line by line, and that's what we were used to in the past, to the microservices architecture. And in that architecture, we have a lot of different separated services. Each one of them should be independent, should have its own resources deployed differently. And I think that, especially after all these talks, we know that we have a lot of advantages from designing our systems in such way. But how do we monitor this kind of architecture? Do we monitor each one of the service separately? I think that it's clear that in that way we won't see the whole picture, because each transaction and each operation that's happening in our systems is going to different services. So what can we do? But first, I want to say that I want to talk about serverless. And serverless is a specific case of microservices architecture that have new challenges that we didn't have on other microservices that transfer containers, for example. So serverless is great. I'm gonna talk mostly about problems in this session, but I want to say that I use it all the time. On Epsagon, we also develop all serverless. So we have a lot of advantages from doing that. We have hundreds of functions, a lot of different resources and everything. It could really give you much more development velocity. You just do SLS deploy usually, and the code is up and running if you're using the serverless framework. So no more configuring servers. It was really talked a lot before. We have the auto-scaling advantage that maybe today I have one function invoked per second, and in 2 weeks from now, it could be 2,000 or I don't know how much. So we have this, and it's pay-per-use, much more scalable even for the business, and it will usually be cheaper than other solutions as well. So we have a lot of advantages, but still we have problems, and we'll get to that. But now about monitoring, let's try to tackle this different thing one by one. We start with the system health. So of course that in serverless, the main components of our systems are the functions, right? So of course we need to know when our functions fail and to be notified about it. But is that enough? Is my system is only my functions? We will get to that. But first, let's understand something that is very important. On serverless, we are in the era of APIs. We want to use managed resources as much as possible. If what you do is only to run your code on Lambda functions instead of containers, I don't think that this is real serverless because you won't have the real benefits like scalability and many other things that you can get. We want to use as much as managed resources as possible, so we can focus only our business logic. Finally, we can really do that. So we have the cloud vendor resources. So in case of AWS, we have like SNS and SQS for queuing and for distributing messages, and we have different databases, and we have Kinesis for streaming, and a lot of different resources that also help us to build our architecture correctly and scalable. It's not enough just to run it on Lambda. We also have a lot of third-party services like Auth0 for authentication, Stripe for billing, we have Slack for messaging and notifications, and many others. And I think that most of us know that they're very helpful and we want to use them as much as possible, but what comes that applications become highly distributed and highly event-driven. And why is that? It's because our functions became much smaller and smaller. They do less, they only do small things and focus on the business logic, but try to give as much as possible to other services. It could be other services in our architecture or third party and such on. So our system is very distributed and event-driven. And what this means that the system is not only the functions. We have the function, we have the APIs that the functions are using, and these APIs sometimes are also resources that are part of our systems. And what we have are transactions, that we have different functions that are connected together by APIs that they are using. And we also need to keep track of these transactions. So let's see a good example. This example, Simona talked about it before, it's quite famous of Yankui, which also a famous figure in the serverless community. I really recommend following him. So what you can see here is a real serverless application. And we have a lot of Lambda functions, but you also have a lot of many other resources, and many, like before, queues, and we have data storage resources, we have external resources for streaming and authentication and many things. So this is how a real serverless application should look like, not only Lambda functions. Okay, so serverless is not only functions. But now let's see how can we troubleshoot problems in this kind of a system. So let's say we have a problem on a function and we want to troubleshoot it. Now we can go to this function and try to see what's going on. But usually, just looking on a specific function won't be enough, because what happened in the function is connected to other many things that happens in other functions. So we will need to track all these events that happen, usually asynchronously in our system, and connect them together. So first, let's see what I got out of the box. In this example, again, on AWS, if I want to troubleshoot problems. Let's say I have a problem in a specific Lambda functions, probably in the middle of the night, and I want to understand what's going on. So I have general metrics and cloud metrics about the invocation of the Lambda function, how many timeouts and exceptions there were. This is just general stuff. And then I can go to look on the log streams. And if the Lambda is invoked concurrently, I will have a lot of different log streams. Now I have to try to find out where my log is. So I can go to a lot of different log streams, a lot of cloud.logs, and try to look where is the log of my Lambda, of my invocation, or maybe there was few invocations, and I did it a lot of times. Unfortunately, it's not fun at all. So now let's say that you did it and you find the log that you were looking for, you know what was the problem, but a lot of times you will find out that this Lambda did everything fine. The problem was the input of the Lambda. So I need to go back to the previous Lambda function and to do root cause analysis and to find out what caused the previous Lambda to send this kind of input. So again, this is why what I get out of the box is not enough. So I want to see transactions, and transactions I have a lot of Lambda functions connected by different APIs that connect them into a single workflow. And I want to be able to work with that workflow all together, already combined, so I'll be able to troubleshoot correctly. Now, this is an example of a transaction, also from Yankui. So let's see what we got here. We have an API gateway that received an HTTP request. Now, there was a single Lambda that was first invoked, but then I get, in this case, 4 other Lambda functions that they were invoked. So I got 2 first Lambda functions on the left that were invoked due to a change on DynamoDB on S3, again, used for a database and data storage. So these 2 Lambdas are invoked asynchronously, and then I have another 2 Lambda functions that were invoked in response to SNS, that distributed a message to 2 different audio Lambda functions. Now I need to be able to trace these invocations and again connect all of them to the same transaction. And in this case, I also have the third-party libraries that are also part of this transaction. So I have Auth0 for authentication, and in this case, I also have an Azure function that was running in response to that, and it's the part of the same transaction. Because if I want to debug or understand what's happened in this case, in this post request, I need to look on this as well. So I need some kind of way to trace all of these things together and combine them. Now, this is what is called distributed tracing. And distributed tracing is not a new thing, because we had it also before from microservice architecture, because we have a lot of different services, and we had to, again, do the same thing and combine all this information. So a trace means that it tells the story of a transaction or a workflow as it propagates to my application. And I can divide it to different sections or different sections of work. That's each one of them describes a single event. In serverless, it will mostly be different invocation of Lambda function. So in this case, I got a client that first make a request to the load balancer, and again the request go through the authentication, billing, and such on. And I have 8 different operations that I want to combine and connect to one trace. Now, after I have this trace, I want to inspect it and to be able to use it for debugging and troubleshooting. So in this example, there is a platform called Jagger, which this is the part of the UI of it, that I can give it this trace, and then I will have a timeline of all the operations that took place and the connections between them. And mostly I will also have more information about each one of event, like what was the input, the output, maybe logs, and again, all of these things should be already connected to a single trace. So this is Jagger. It's quite popular for distributed tracing. Now, how can we do it? So I try to understand, to make you understand why it's important and how it should look like, but how can we really do it? So there is a standard called open tracing, which is an open standard, of course, that tells how these traces should look like, and also what should be the API in many different programming languages to how to make these traces. So what I need to do is it's called instrumentation, and it should be done manually. So I need to instrument or to hook before or after calls that I make in my code, and to collect information, collect traces. Then I will also have to collect the trace at the end of each microservices for each invocation that I want to trace, so that I will know when this kind of service ends. And what I get is like this code example on JavaScript that I need a lot of manual work to. In this case, there's it's called a span that describes that single event in the system. So I need to give it a name, and then I need to give it some kind of an identifier that I will be able to use it when it received on other services that received it, in order to combine the different traces and to combine them into a single transaction. And I will have always to use it when I make calls. So it really affects my code, and it has a lot of maintenance, and especially on serverless, because on serverless I have many API calls, much more than before. And on serverless, one of the main things was to keep the development velocity, right? So right now I will have high maintenance, and due to that high potential of errors, because the code changes every time, and then I will have to keep track on the tracing as well. So it will probably have some bugs. Now, like I said, I might have thousands of functions, and whenever a Lambda function makes an invocation to another Lambda function, or put an item on a database, I will have to trace it. Sounds like a hard work. So besides of that, I have another new challenges that I didn't have on a microservice architecture before. I have out of memory and timeouts problem, and when that happens, it's like somebody plugged out the electricity of your server at the middle of its work. So what can we do? How can we collect the trace? We didn't know that it's going to happen, right? And we have also new problems like cold starts, that once in a while my code needs to initialize, the container needs to initialize, and the running time will be much higher. So even if it's happened rarely, I need to understand what is the effect on the system or my users. And I have a new thing which is retries. If I have a failure, then the same code may run again, and we need to understand what's going on with that. So this is why distributed tracing is very important and very needed for serverless, but using it as it is may be not enough. And we need something that will be a little bit different. So what we need is automation. We want to keep the tracing procedure automated. So we don't have always to keep it track and to do all the manual work. And this is the only way that we will be able to keep up the development speed, and we will also have monitoring abilities. So let's see an example of how we can do that. So in this example, I will show you a part of the product that we build on Epsagon. Okay, let's go. So what you can see here is a list of transactions in serverless systems, and each one of the items in the list describes not a single function invocation, but already a combined transaction. So let's go to a first invocation. A first transaction, sorry. So here we want to see what were the resources in these transactions. So we see the API gateway again and two Lambda functions that were invoked. Then I want to be able to go to each one of the Lambda function and to see the logs. Okay, in a single click, I can see the CloudWatch log. I don't have to look for it manually anymore. And in this case, I also had retries. This Lambda function was invoked twice because the first invocation failed. And I want that these retries will be already on the same transaction, so I will be able to troubleshoot the problem efficiently. Now, also, maybe again, the problem was in the SNS and not in the Lambda function. So I want to be able to go to the SNS and see what was the message that was sent. Maybe I want to send it again, maybe on another environment to see what's going on. So this can be very useful. And again, go to other Lambda function, do the same thing. Go to the API gateway, go to see what was the initial trigger, so I can run it again. And apparently, this can be created fully automated. You don't need to do the manual tracing, because only by instrumenting the request to your cloud vendor, in this case AWS, you can have a lot of information that will be useful to create this architecture. So this is very nice, and even I don't know if some of you know it, but AWS gives a lot of identifiers to your request. So for example, if you publish a message to the SNS, so there will be an identifier for this message, and when this message invoked another Lambda, this identifier will be given to this Lambda. So you can use this identifier to connect the dots and to create the transactions that are so needed. And this is what we do on Epsagon. All right. So I think that I hope that now you understand that distributed tracing is very useful and important to monitor serverless application. But let's see how it's also useful to the case of optimization, which is also part of it. So serverless time is money. You literally pay for each 100 milliseconds that your code is up and running. And we need to understand how it affects our systems, because what happens now is because we need to pay for all the time that we are running, even when we're sleeping and we're waiting, we're still paying. So we're using a lot of different API calls, and when I make an API call, I usually have to wait until I get a response, and I'm still paying about it. So it started to be very important to understand what's going on and what do I spend my time on. So again, there's the infrastructure overhead, which is related to the call stats. When my Lambda functions are run on the first time, I have my own code that takes some time to run. That's okay, and I have the API calls. So we need to understand for each Lambda functions what we're spending out time on each part. Let's have a quick look again on a transaction. So what we can see here is the transactions that it's completed end-to-end in less than 1 second, but we have a single operation, a single API call to Auth0 for authentication that took us 700 milliseconds, and that's a big portion of that transaction. So let's say that this transaction is invoked 1 billion times maybe per day or per week. So just only these single API calls can cost us about $40. So we need to understand what do we spend time on. And for example, this timeline of distributed tracing may be very useful for that, because if I do my tracing right, I will be able to see what I spent time on for every part of it. Now, if you still don't believe me that it's important, I will show you now a real example from our company. So there's a little bit of Hebrew here. This is a message, a WhatsApp message that was sent from our CEO to our CTO. And it was at the beginning of our company. And what you can see here is a screenshot from our product with a single Lambda function with estimated monthly cost of about $12,000, which at this moment it was much higher than our whole AWS bill, and we didn't understand what's going on. So this screenshot was taken from our product, and because, like I said before, that we also develop serverless and we monitor serverless applications, we can monitor our own application. It's really nice. We're the customers of ourselves. So we got a notification about the Lambda functions that suddenly have a very expensive monthly bill. So immediately we just went to try to understand what's going on. And yeah, so we went, holy shit, of course. So what this Lambda function was doing, it was to make the monitoring on Epsagon. We do two things. First, we instrument the code of our customers and we send the traces, but we also scan the CloudWatch logs. By scanning the CloudWatch logs, we can get a lot of other data, like the memory usage, the time usage, how many invocations, get data about functions that are not instrumented. So it's very useful. And at the beginning, we said, okay, how can we do that? We can just every 5 minutes, wake up, go to the to all of the new logs of all of our logs of the Lambda function that we scan, and parse the information and save it to the database. Now, we need to make it concurrent because we can't just go on thousands of Lambda functions, one after the other. So we said, okay, let's invoke an async Lambda for each Lambda of our customers that would just scan its logs, put the information on the database, and quit. Sounds simple and fun. And the beginning, it worked well. There were no problems. But then we had our first big enough customer that has like, I don't know, 10 or 100 more invocations than the customer before. And CloudWatt has some throttling limits. It means that you can access it per second only on a limited rate. And when you cross this rate, what happens is that requests are starting to take a very long time, maybe instead of 100 milliseconds, 10 seconds, or even more in some cases. And some of them, at the end of this time, will success. Some of them will fail, and then the code automatically tries to make the same request again. It's connected to the scaling problem that D2L was talking about before. So the request took a very long time, and then the Lambdas were running for 5 minutes, which was their timeout limit, basically the maximum timeout limit you can give. And we ended at about 5,000 concurrent Lambdas that were scanning this 5,000 Lambdas of this specific customer that were running forever. And apparently, it could be quite expensive. And we didn't know that this problem could happen, and we didn't know that if it will happen, this will be the effect. So, just a second before we continue. The solution was to have the information pushed instead of pulled by us, but this is quite not the topic of this session. So, a little summary: we understand now that distributed tracing is an important part also for optimizing and to understanding what each Lambda function is doing. So is that all what we need? Is that enough? Did we solve the problem of monitoring if we have this kind of automated distributed tracing? So in fact, we still think that is not enough. What we need is observability. And observability means that I want to understand what's going on in my system, and not only the parts that are failing. Is it doing what I designed it to do? I want to be able to go and dig out on each part to have the right statistics and right metrics. And when some kind of application changes and I make a big deployment, I want to go to check out the other parts and see that they're doing what I meant. So I will give you some example of how we can gain observability on serverless applications. So this is the dashboard of our product. And what you can see, for example, are insights like of functions that are close to their timeout limit, or that they are close to the defined memory limit. And we want to have this information before this problem happens, because now we have more time to understand, okay, so why is this happening? Do I need to increase the timeout limit, or maybe there is another problem? And I also want to know what is the percentage of the Lambda functions that are failing. Sometimes a very small percentage may say that there is a big problem, but on the most of the cases, I can say that if there is a very big change of the amount of Lambda functions that are failing, so look like there is something new happening in my system, and I want to be notified about it. I want to see how many costs are there, what is the cost, and these kind of things. Now, let's see some more. So, for each Lambda function, I want to have general metrics about it. I want to see how many invocations they were. I want to see the memory usage, but it's not enough to see only the average memory usage, or to see the memory usage of some specific invocations. I want to see percentiles, because, for example, if I have only in the P99 percentile, I get to the memory limit, but on the P50 percentile, I'm much below it. So maybe the problem is not that there is not enough memory. Maybe the problem is that there are some cases that this lambda can't process correctly. So I need this kind of metrics and this kind of information, and it's not only about solving new problems. And same thing with the duration. I want to know how my architecture looks like, and does it look like I designed it? And I want to have some information about each part of it to know what is, again, what is the average time on each resource. Then I will have a better understanding about what's going on. And again, this kind of thing can be created automatically because these connections are already made by your code, right? You just need to connect the pieces. So yeah, this is how it looks like. And moreover, I want to see business flows. And what are business flows? In most of the system, I will have some flows that occurs a lot of times and have some important significance for my business. In this example, I may have the subscription flow, which is most of the time will be very important. Now, I want to go on and have some understanding about what is this flow, how many times it happens, and maybe I have other flow in the case the flow of a transfer payment. So I want to analyze what are these flows and to understand if like I designed the system to be, right? So in this case, you can see that I have a list of a different flow. And if I go for one of them, I am able to see what is the transactions in this flow, how they look like. And I have some general statistics, like how many time these flows take on average. So if for example, this flows is a new post that's uploaded to a website, I don't want to see only how much time it took to the first Lambda function to run and to process this, because probably when it finishes its invocation, the post is not already on the system because I have a lot of many other resources that need to process this request. So I want to see the average duration of this full workflow, and how can I do that? And I want to see how many times it invokes, right? And a lot of different statistics. So this is it. Feel free to reach out. Again, this is my email address, and you can look us online. Thank you very much for listening.